Screen. Okay, so just I want to give some reflections, and Luca will give many more reflections before going into the breakout rooms. First of all, innovative data sources. What innovative means? We can say that innovative depends on the moment we are talking. Maybe 10 years ago, camera data was innovative. Today, floating car data is innovative. Bluetooth. There is this definition that innovative means that is some kind of technology collected digital data, not survey, not manually, then applied to any kind of data at any moment. What I think is important is not the data itself, it's not the data source itself, it's not the sensor, but the applications of the data. I think that talking about data on its own, it has nothing. But we should always link the data, the sensor creating this data to the application. This is what is important for everyone for that are here. I still remember, I think it was 10 years ago, a presentation where we saw a real raining map in Germany in real time, just plotting the sensors in the cars, telling that from a private manufacturer of cars, the wipers were on. So the data, it looks okay. One car is using the wipers. This has no value. But when putting together the whole fleet of one manufacturer, we could see a rain map, but not only this, an intensity rain, because they were plotting different colors based on the speed of the wipers. So you see that one data that it seems not important can solve something very important for another domain, weather prediction, weather data collection. So it's really interesting to talk about data, but we always need to think about the application of this data, the use of this data. So very broadly, what are the trends? What are the main groups of data? Roadside detectors, this is mostly called conventional data. It's about loops, about cameras, about radars. We can say that it's not innovative, but still is giving us the same quality and the same use of data in some uses as the other. Floating car data, Bluetooth, Wi-Fi sensors, GPS location, all these data sets are mostly creating three data units. Someone was at a location at a moment in time. And in most of the data sets, these three aspects are the most important. Who is, where, and at what time. With this, we can understand patterns of people moving within the city, both in space and time. We can understand travel time. We can aggregate and have traffic flows. So these three data units, I would say, are the most important. ID, location, and time. This can be collected as well by mobile operators, by smart car data from public transport, other services, and remote sensing. So it's about sensors, so the collection tools. It's about the data created, the raw data. I recall Jordi commenting that raw data is important to have it as an owner of the data as a city. But at the end is the application. What do you do with this data? Of course, the second sentence, it says that this data on their own is nothing. It should be analyzed. It should be processed. And of course, it should be complemented. If we can complement it, and this is very important, if we have different data sources, we can validate, we can enrich our analysis, and this is really the value. So my next reflection, and I will use our Living Lab as an example, is about the most important aspects in Living Labs, which is highly related to data, which is the ecosystem. In Thessaloniki, and I think I'm sure you have already seen this presentation or reference to our Living Lab, we are having the small, which is the Thessaloniki Smart Mobility Living Lab. And our most important, or one of our most important assets, is the ecosystem. We have put all the actors together, all the stakeholders together in sharing the data. So we are the aggregator, we are the data neutralizer, we are the hoster of the host of the Living Lab, but we have all the data. We can process the data, we can merge the data, we can fuse the data, and we can really create value out of it. So I would say that it's very important that you in your cities, you can find this ecosystem, you can find these data owners, and you can agree with them to share this data for the good of the city. You can create these win-win situations. We are giving back value to them. Give me the data, I can analyze, and I can give you back value. So I'm creating a long-term relation with them. Of course, it's about co-creation, co-design with the citizens. Once you have this data, you can create, and you need the citizens to help you in this. It's about novel technologies, it's about innovation. And just to mention that we are in different initiatives trying to have the greater ecosystem. It can be the national one in our cluster in mobility and logistics. It can be the national and regional one with our risk hub from the EIT, or it can be pan-European or even worldwide within ENOL, which is the European Network of Living Labs. So it's very important that you keep your ecosystem with you, but you also are part of other ecosystems at different levels. So you can co-create, you can interchange best practices, and somehow is what we are doing today here. We have different cities, different data owners, data creators, and we will see different and many implementations and applications of data. This is our ecosystem in Thessaloniki. It's quite rich. Our city is a medium-sized city, but we're very happy that we can say that all these people, all these persons, at the end of the day, these are persons, believe on the Living Lab, are giving us their data so we can build many services and value out of it. And I will not take more time, so I'm giving the floor to Luca, who will present different insights and will put some reflections that I think you can take with you to the breakout rooms.
Okay, good morning. Well, I'm Luca Bellinato from the municipality of Bologna, and in this intervention, I'm trying to explain to describe our experience in the big data and innovative data collection and management. What we are trying to set the shape, to give the shape that we are trying to give in our approach, and the method we are trying to elaborate to set a sort of new mental maps about, of course, data collection, selection, management. I begin with the short description to traditional data collection. We based in the last at least two decades, our work on national census surveys that ask for commuter trips, give detail of the means of transport and the purpose. Then we have surveys. We base our analysis on surveys mobility on the field, so counting car flow with loops or even counters and drivers' interviews. Then we have we had in the past telephone surveys, sample surveys, and they were specific but sometimes restricted. Jumping to the results, so to data management, we represent mobility environment with trips matrices, usually in peak hours. So our sustainable urban mobility plan approved in 2019 is based mainly on those methods, and I think that most of you knows the tools of municipality border, census sections, or for modeling, model zoning, and so on. In our census form, the question were simple but quite clear. Where do you begin your trips? Where do you go? Where do you end your trips? What means of transport you use when you had your trips, and why? For the surveys, Bologna has a dense network of loops working 20 hours per day, 7 days per month, and yearly. So a vast amount of data, very accurate, spread, distributed in at least 20 years. The final result is that through the use of census form, telephone surveys, traffic flows, and so on, we can, is it possible to create maybe a narrow, but a very accurate trip representation? The environment has changed, and now we are talking about innovative methods. So innovative is big data collection. There is a new, there are new stakeholders or actors on the field, and they are telecommunication companies as mainly data providers. There are many telecommunication companies. The point is which one to choose for the data. So the flows is different. The process is different. We have SIM data, mobile towers, antennas, and then the group of them gives a mobile network. And from the SIM data, which collect a single data of single users, we go to the cloud, where a huge amount of data are stored in this cloud of big data. So the first point is we have to choose to know which are the data we need, the suitable data. In this way, we have to choose the suitable company that give us the suitable data. The risk is that in this let me say ocean, the risk is to drown on this ocean of data. The point is we need to learn how to swim on them. So we need to choose, we need to know how to choose the company that give us the suitable data. Second step, big data selections. I named statistic agencies as data processors. There is a third actor between the telecommunication companies that collect data and the municipality in our case, and there's the statistics agencies, let me say, that processes data. There is a first step, there is a first relationship with them when we express our needs. We need mobility behaviors, we need customer profile, segment analysis, and based on this, they can process data. They begin with data processing. The result will be new origin destination trips, means of transport, travel time, routes, average speed, and many other things. In this case, second point, focus our attention on analysis reliability. So are all these results reliable? Is this data what we need for our policy making? Then there is a third step, which approach to develop. If we don't, well, not want, but maybe we don't have time to go into detail, maybe we have to trust on the data they offer us. On the other side, if we have time mainly, but also curiosity, or if we want to set our system in another way, we need to know. But to know, we need to study. So what kind of data is big data? Not all data are available or useful for travel analysis. It is necessary to extract meaningful data. To do that, we need to make questions. So how to determine origin and destination trips, how to fix means of transport used, how to figure out if just an example, if two or more people are traveling in the same vehicle or not, how to estimate origin destination position if it depends on the power of antennas, and so on. So the topic is new, but we understood that it's not new only for us, it's new also for suppliers, for providers, data providers that are gaining experience through us. They are gaining experience with us. So it's necessary to get used to asking questions. So third point, make questions, no shame to ask, because we need to become more confident in this ecosystem. This is just an example of the questions we asked, for example, for geolocation, order of approximation with mobile towers in Bologna. for the last step is how to analyze big data. The approach can be different. We can have analysis by data providers, so an external expertise, analysis by administration as an internal expertise, or analysis with a big data as a service mixed expertise. Well, this scheme is just to clarify for ourselves how to approach on the matters. We think that we experienced that data provider often don't have experience specifically in mobility field, because they offers data to different clients, and we are one of their clients. On the other side, administrations usually don't have a constant need for analysis and don't have as broad a view as they have in with these data processors acting on multiple areas and daily. So we got to the conclusion that a third part in data analysis is probably the best solution for an efficient interactions. The fourth point, administration must maintain analysis capacity, because we are the let me say storytellers, we are the policy makers, so we need to be convinced of the data we described. Go to the conclusion: analysis, correlation, comparisons. Traditional data are based on surveys, big data are based on infinite set of actual movements. It's useful to make comparison to find similarities. It's helpful to find relationship to set the same state of the art. Well, some even from different origins, some results need to be more or less the same, of course, but is useless to persist in comparisons. Is not the best approach in the long run. We concluded that data can be complementary. It shows different aspects of the polyhedric mobility system. And in conclusion, big data providers and big data analysts, well, they are the new partners we have to work with. Opportunities or threats? Well, big data can be both. It depends on the relationship we are able to set with them, and the level of knowledge we can reach. Big data as a service, yes, we think it's good because there is data tailoring necessity. It's important to clarify who is asking what, who is offering what, and who certifies what. Then there are details about the frequency of analysis, a continuously relationship with the data providers, occasionally, it depends, and the budget we needed to fix. This is the experience, this is the approach we are trying to shape for our environment, for our ecosystem. Maybe is different in other cities, and this is the way we are trying to set our new, let me say, mental maps. Thank you.